Welcome back, class. Hope you had a great Easter. This, I have to say, is probably the first time in my lifetime. I can't speak for the first couple of years of my life, or at least the first year of my life. But this is probably the first time in my life that I have not been in church in a building on Easter. So I hope you had a great Easter break, a great Easter weekend. I hope you got to at least talk to family. Maybe you got to FaceTime or Zoom or something just to connect. But I hope it was a great Easter season. I hope you got to celebrate our risen Savior and what he means to us. So, welcome back. We have a lesson today, and then on Friday we will be going over chapters 11 and 12. We'll do some practice, preparing for a test that I will open up over the weekend. And I'll explain more of that on Friday. But basically, I'll have you submit. I will give you certain problems to do, and then you'll submit them as a test. So, just as we go back, just to kind of reiterate, it's been a couple of days, but right now we're in chapter 12, and we are studying annuities. All right, and I'm not going to go over, I've done that already, but what an annuity is, equal payments over equal amounts of time. We're talking about simple annuities, and we're talking about ordinary, we're talking about annuities certain, simple annuities, and basically the annuities that we work with in each section are ordinary and annuity due. And because we have equal payments over equal amounts of time, where the compounding and the payment is congruent, ordinary means the payment is at the end of the compounding period, and annuity due is the payment at the beginning of the compounding period. Chapter 12 is broken into three sections, very conveniently. Section 1, we talk about future value. All right, we know what the payment is, what we're putting away, and we want to figure out what those payments are worth over time in the future. So we talked about the future value, and we did tables and formulas. So we did future value for ordinary annuity and annuity due. All right, there were the tables. All right, we talked about formulas. There were the formulas we used. All right, and then we talked about the present value. All right, and the present value, we said, was when we want to figure out what payments are, if we know what the payments are and we have a future amount, what is that actually worth now? All right, what is that worth now? A lot of times annuities are traded based off of their present value. And as you see in the section 3, we have to actually know a lot of times what our present value is in order to pay down a loan. So that's the other area where present value. So we worked in section 2 of chapter 12. We did present values of annuities, ordinary, and annuity due. All right. So we did tables as well as formulas for that. Now, those are the things that you have to remember. The future value, what you want it to be, and what that formula is. The present value, what it is currently worth now as a lump sum. All right. But then we talked about on Friday in section 3, in both of the future and present value, we knew what the payments were. But what if we don't know what the payments are? All right. And that was the beginning of section 3. Okay. And we talked about sinking funds and amortizations. Okay. And so sinking funds are basically what payments do we need to have a future value. We don't know what the payments are, but we want to figure out a future value over a certain amount of time and compounding interest. And amortization is figuring out the payments when we know the present value. And amortization, we said, is used for loans. All right, so car loans, house loans, mortgages, things of that nature. All right, so we use tables to do sinking funds and amortizations. All right, when we're trying to find the payments, all right, for sinking funds, which are future value, and amortization, which is present value. okay? When we want to find those payments. So we used the tables before, okay? What we're going to work on now are formulas. So the first formula, section 12.9, all right, and that's on page 389. The first formula we're going to look at is calculating a sinking fund, the future value. See, future value, all right? The sinking fund using the formula. So the payment for a sinking fund is equal to whatever future value you want times, now you got to pay attention to this. These are all actually derivations of our original formulas. So each chapter you can walk through and say, oh yeah, if I do some algebra, this is what I would end up with. So these are just derivations of our future value formula as we talk about annuities. Okay, but we don't know what our payments are. So the future value times, now you notice here, it looks like our numerator and denominator have flipped. As before, when we used our future value and present value formulas, I is now in the numerator, and 1 plus I raised to the n minus 1 is in the denominator. So it's flipped, okay? So you have to pay attention how you plug this into your calculator. Now we have to do the denominator first, figure that out. That is our order of operations. We got to do the exponent first and the parentheses first. So we will figure out what's in the denominator first, and then we will take I and divide that by what we find in the denominator, and then multiply that by the future value. All right, so that is the formula. Now again, as we've done throughout our annuities, we have to find I, the interest rate per period, since we're compounding, and we have to find N. And I always like to find 1 plus I. Just makes it easier in the long run. Okay, so they break it down here. Okay, so here's the problem, and they up here at the top of 390, they talk about what the future value is. We know what that is. What's the future value if I put these payments away? Okay, so in our problem here, Oceanair needs $100,000 in 5 years to pay off a bond issue. And now just quickly, what they've done is they've gotten people to pay them money up front, and then they basically are selling bonds. It's not quite like a stock. You're not selling interest in your company. You're just saying, hey, I'm issuing this legal document, and if you give me $100 now, I'll give you $150 later. So they're just selling a bond issue, okay? We do that all the time. There's treasury bonds. We talked about that in our markup markdown, what bonds are, okay? So this company sold bonds to raise money for themselves, knowing that they would pay off more money later to these people. In order to entice them to buy a bond, they have to make it worth more in the future, okay? So in 5 years, they need $100,000 to pay off these bonds, okay? What sinking fund payment is required at the end of each month, all right? End means ordinary. At 12% interest compounded monthly to meet the financial obligation, all right? So we know it's 5 years, and we know it's compounded monthly. So 5 times 12, N is going to be 60. We know that since it's compounded monthly, it's 12% annually. So 12% divided by how many times in a year it's compounded? Monthly 12. That's going to be 1%. So I is 1%, or 0.01. And 1 plus I is going to be 1.01. Okay? So to solve the sinking fund problem, we use 1% as I and 60 periods for N. Okay? So they fill it in. I divided by, so 0.01 divided by 1.01 raised to the 60th power, and then they'll subtract 1. So when they do all this math, they get 0.81666967. So 0.01 divided by 0.81666967, all right, which is 0.0122444, and they multiply that by 100,000. So that means that they would have a sinking fund payment of $1,224.44 each month for the next 5 years. All right? And if they, how much money out of pocket is that? All right. If they multiply that by 60, all right, so it's about the 70,000 range, 72,000. It's about $72,000, 74,000, I'll say. I'm guesstimating. All right, so in 5 years, that should be worth $100,000. So they've made in 5 years $25,000, and at 12% interest, that's pretty good. They should. All right, so that's just wise for them. Okay, so let's practice using the formula again. I'll pause it here, and I'll come back with the answer to our triad exercise 9. Lake Louise Ski Resort Center will need $40,000 in 6 years to replace aging equipment. All right, so they're going to create a sinking fund that they put money away now so that in 6 years they can do some updates to their equipment. What sinking fund payment is required at the end of each month at 6% interest compounded monthly? All right, to amount to the $40,000 in 6 years. All right, so go ahead and break that down. It's compounded monthly, 6% per year. They need $40,000 in 6 years. All right, go ahead, figure that out with the formula, and I will be back with the answer.